The Kuiper belt is a zone situated beyond most of the solar system's planets. Pluto was the first object discovered in this region, but it wasn't until about 60 years later that any additional objects were identified. On November 2, 2015, the world was introduced to a Kuiper belt object through one of the most remarkable space photographs ever released. This milestone has now been surpassed by the James Webb Space Telescope, JWST, which has provided the clearest images of the Kuiper belt in history, revealing features that were unexpected. Located in the outer reaches of the solar system, the Kuiper belt resembles a cold, donut-shaped zone that extends past Neptune's orbit, the eighth planet from the Sun. Initially, the most intriguing aspect of the Kuiper belt was its shape. However, it quickly became evident that this region is one of the solar system's most captivating components. Named after astronomer Gerard Kuiper, whose mid-20th century research laid the foundation for understanding what lies beyond Pluto, it is important to note that he did not discover it himself. In 1951, Kuiper published a paper theorizing the existence of objects beyond Pluto, focusing mainly on the possibility of such objects without detailing their specific properties or arrangements. Initially, Pluto was considered the key reference point for the Kuiper belt, but it is now understood that the inner edge of the belt is defined by Neptune's orbit. The gravitational influence of Neptune is vital in shaping the dynamics of the Kuiper belt. Although Kuiper's predictions did not match later findings precisely, his groundbreaking ideas gained recognition among astronomers, linking the concept of the Kuiper belt with objects beyond Pluto over time. In 1930, Clyde Tombaugh discovered Pluto, marking it as the first identified object in what we now refer to as the Kuiper belt. At that time, our understanding of the outer solar system was limited, and astronomers did not foresee a significant number of icy bodies beyond Neptune. The traditional view of the solar system included the rocky inner planets, the gas giants, and the icy giant Neptune. The discovery of Pluto, despite its elliptical and tilted orbit, led scientists to view it as a solitary planet. It wasn't until 1992, 62 years later, that the second Kuiper belt object was found, which demonstrated that Pluto was not an isolated body but part of a larger population of objects in the outer solar system. The subsequent identification of numerous Kuiper belt objects, KBOs, confirmed the existence of this region, which contains a diverse array of icy worlds beyond Neptune. Pluto's initial classification as the ninth planet in astronomical history lasted for several decades. However, as our comprehension of the Kuiper belt evolved, and with the discovery of more KBOs, especially those larger than Pluto, the International Astronomical Union revised the criteria for defining planets in 2006, resulting in Pluto being reclassified as a dwarf planet. Despite this change, Pluto remains one of the most significant discoveries in our solar system, as it prompted further exploration of the Kuiper belt. This unique region is considered an extension of our solar system, as it is influenced by the Sun's gravitational forces. While the 8 major planets, including Neptune, dominate the inner solar system, the Kuiper belt stretches the solar system's boundaries into the far reaches. Characterized by a collection of icy objects, including dwarf planets, asteroids, and comets, the Kuiper belt is believed to contain materials dating back to the early solar system, approximately 4.6 billion years ago, preserving conditions and materials from that time. Within this belt lie Pluto and its moons, along with other dwarf planets like Haumea, Makemake, and Eris. The Kuiper belt is significantly larger than the main asteroid belt, which consists mainly of rocky objects located between Mars and Jupiter. The asteroid belt is relatively sparse and includes many small to medium-sized bodies, while the Kuiper belt is a more extensive and distant region, estimated to have a mass 20 to 100 times greater than that of the asteroid belt, indicating a greater abundance of material in terms of both the number of objects and their overall mass. Although the long wait for discoveries in this region was surprising, it does not diminish its importance to the solar system. The Kuiper belt is home to a diverse range of celestial bodies, including dwarf planets like Pluto, Haumea, and Eris. Pluto, discovered by Clyde Tombaugh in 1930, was once regarded as the ninth planet until the International Astronomical Union redefined the criteria for planetary classification in 2006, which led to its reclassification as a dwarf planet. With a diameter of about 2,377 kilometers, Pluto orbits alongside other notable dwarf planets within the Kuiper belt. Research into Pluto has significantly advanced our understanding of this distant region. However, this was just the beginning. Haumea, discovered in 2004 by a team led by Mike Brown, adds to the Kuiper belt's diversity with its distinct elongated shape, likely resulting from rapid rotation. This dwarf planet has a diameter of approximately 1,960 kilometers and has provided valuable insights into the intriguing characteristics of Kuiper belt objects. Makemake, another discovery from Brown's team in 2005, has its own unique traits, with a diameter of around 1,430 kilometers. Despite lacking a significant atmosphere, its bright surface, made up of methane, ethane, and other materials, distinguishes it as one of the brightest objects in the Kuiper belt. Eris, also discovered in 2005, is slightly smaller than Pluto but more massive, with a diameter of approximately 2,326 kilometers. Eris is a crucial member of the Kuiper belt, and its discovery prompted a re-evaluation of what constitutes a planet, broadening our understanding of the diversity and dynamics of objects within this region. Together, these dwarf planets provide essential insights into the composition and evolution of the Kuiper belt and its role in the broader context of the solar system's history. Without these discoveries, our knowledge of this area would remain limited. Many people confuse the Kuiper belt with the Oort cloud. However, the Kuiper belt is more densely populated with objects and is believed to be a source of short-period comets that have relatively brief orbital periods. In contrast, the Oort cloud is a more distant and spherical region that envelopes the entire solar system, believed to extend from about 2,000 to possibly 200,000 astronomical units from the Sun. The Oort cloud comprises icy bodies often compared to dirty snowballs and is hypothesized to be the source of long-period comets, which have highly elliptical orbits that bring them closer to the Sun. The NICE model is a theoretical framework that proposes a series of significant orbital changes in the outer solar system, particularly involving the four giant planets, Jupiter, Saturn, Uranus, and Neptune. According to this model, the giant planets did not always occupy their current orbits. Instead, they underwent dynamic orbital evolution. The model suggests that interactions among these giant planets led to considerable changes in their orbits, resulting in the loss of a substantial amount of material in the Kuiper belt, originally estimated to be 7 to 10 times the mass of Earth. Gravitational interactions and the shifting orbits of the giant planets may have caused Kuiper belt material to be scattered, ejected from the solar system, or redistributed to different regions. Currently, the Kuiper belt is slowly eroding, with collisions between objects generating fragments that can form smaller Kuiper belt objects. Some of these smaller objects may develop into comets, while others may not. Dust produced by these collisions can be blown out of the solar system by solar wind. The total mass of all materials in the Kuiper belt is estimated to be no more than about 10% of Earth's mass. Although this may seem small, it is still significant. Many Kuiper belt objects have been found to possess moons, smaller bodies that orbit a larger primary object. This phenomenon is not limited to planets, it also extends to various objects within the Kuiper belt. Along with their moons, some KBOs exist in binary systems, where two objects of similar size or mass orbit around a common center of mass, referred to as their barycenter. These binary pairs can exhibit diverse orbital characteristics, with some objects touching, forming a distinctive shape known as a contact binary, where the two components are physically connected. NASA has invested considerable effort into exploring the Kuiper belt. Pioneer 10 was one of the first spacecraft to approach this region. Launched by NASA on March 2, 1972, Pioneer 10 embarked on a mission that lasted over 3 decades. Designed for the exploration of Jupiter and its environment, Pioneer 10 was equipped with scientific instruments to study Jupiter's atmosphere, magnetic field, and radiation belts. In 1983, it made history as the first spacecraft to traverse the asteroid belt and, later, the first to enter the Kuiper belt region. However, while it did enter this area, it did not visit any icy worlds, as none had been discovered apart from Pluto at the time. The primary focus of Pioneer 10 was Jupiter, and it transmitted valuable data about the gas giant back to Earth. Its trajectory and longevity allowed it to travel far beyond the known planets, enhancing our understanding of the solar system's outer reaches. Its journey through the Kuiper belt laid the groundwork for future missions aimed at exploring this distant and intriguing region. Subsequent missions, such as Voyager 2 and Cassini, further expanded our understanding of the outer solar system. Voyager 2's notable flyby of Neptune's moon Triton in 1989 and Cassini's exploration of Saturn's moon Phoebe in 2004 provided valuable insights into these bodies, with some believed to have originated from the Kuiper belt after being captured by their respective planets' gravitational pull. This possibility is not widely recognized, but it has indeed occurred. However, much more information was yet to be uncovered in this region.